Hello friends, so here is another topic related to the concept of gravitation, which is the universal law of gravitation. Okay, so we all know that as per the concept of gravitation, every body in the universe, it attracts every other body with a force which is called as the gravitational force. Okay, gravitation is the force of attraction between any two bodies in the universe, and gravity comes into play when one of the bodies in the two object system is Earth. Okay, when Earth's gravitational pull acts on any other object, that is called as gravity. Okay, now there is a law which gives us the value of an expression of what force is exerted by one body on the other. Okay, and that is given as per Newton's universal law of gravitation. Okay, so this gives us an expression, a mathematical expression for the gravitational force exerted by the objects on other objects in this entire universe. Okay, so as per Newton's gravitational law, every body in this universe, every object in this universe, it attracts every other object or body with a force which is called as gravitational force. Now the gravitational force, it is directly proportional to the product of the masses of the two bodies of the two objects and inversely proportional to the square of the distance between them. Okay, suppose we have two objects, two bodies. Okay, one is of mass m1, the other is of mass m2. They are separated, that is, their centers, they are separated by a distance r. The reason why I am saying that their centers are separated by a distance r, I will come to that. Okay, so their centers, the center of the two bodies, they are separated by a distance r. Okay, so in this case, the gravitational force exerted by one body on the other is like this. So this is the gravitational force exerted by this body on this, it is trying to pull it towards itself, and this is the gravitational force exerted by this body on this. Okay, it is trying to pull it towards it. Okay, each is trying to pull the other towards them. Okay, the gravitational force. So the gravitational force is directly proportional to the product of the masses of the two bodies, m1, m2, okay, product of the two masses, and inversely proportional to the square of the distance between them, that is 1 by r square. When we combine these two, we get F is directly proportional to m1, m2 by r square. So as per the universal law of gravitation, here the important thing is that the force, the gravitational force, is directly proportional to the product of the two masses. So as the masses, the value of the mass of the two system, the pair, it increases, the gravitational force also increases. Okay, if either of the masses of the two bodies it increases, the gravitational force increases, and it is inversely proportional to the square of the distance. So what it means is that as the separation distance it increases, the gravitational force it decreases. With separation distance increase, gravitational force decreases, and with decrease in separation distance, the gravitational force increases. Okay, inverse relationship. Increase in separation distance, decrease in gravitational force. Decrease in separation distance, increase in gravitational force. Inverse relationship, but direct relationship with mass. Increase in mass, increase in force. Decrease in mass, decrease in force. Okay, so here a proportionality constant will come. Okay, and that proportionality constant, it makes the expression like this: F is equal to G m1 m2 by r square, where capital G is called as the universal gravitational constant. Okay, universal gravitational constant. Now the value of G, it is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square, that is SI unit, and in CGS unit it is 6.67 into 10 to the power minus 8 dyne centimeter square per gram square. Okay, now what is the universal gravitational constant? Now suppose as per this expression F is equal to gm1 m2 r square, the masses are unit masses, that is 1 kg or 1 gram each, and the separation distance is 1 meter or 1 centimeter each. Unit distance apart, unit masses. Okay, unit masses which are separated unit distance apart. In that case, when each of these values, okay, that is the value of m1 and m2 is 1 and r is also equal to 1, then in that case F will be equal to G. Okay, if m1 and m2 is equal to 1 and r is equal to 1, F will be equal to G. That is, the gravitational force will be equal to the gravitational constant. So the definition of capital G, that is the universal gravitational constant, is it is the force of attraction between two bodies of unit mass each and placed unit distance apart. 1 kg separated by 1 meter, 1 gram separated by 1 centimeter as per SI and CGS unit. And G can be written as FR square by M1 M2. Okay, and it has the unit Newton meter square per kg squared or dyne centimeter square per gram squared. Okay, so this is the definition of universal gravitational constant. Next we have the characteristics of gravitational force. Okay, the first characteristic is that the gravitational force between two objects or two bodies, it is independent of the intervening medium. So whatever medium it is placed in, liquid, gas or vacuum, whatever it is, so the gravitational force between two masses is independent of the intervening medium, the medium in which the two objects, the two bodies or two masses are placed. The gravitational force will act regardless of in whatever medium the two objects or the two bodies they are placed in. Okay, then the gravitational force between two bodies, they are equal and opposite as per this diagram. Okay, the magnitude is equal. Okay, the magnitude of the gravitational force is this G m1 m2 by r square. Okay, in both the cases the value of gravitational force, the magnitude is the same, but the direction is opposite. Okay, they are equal in magnitude and opposite in direction. Okay, each is trying to pull the other towards itself. This body is trying to pull this body towards itself and this body is also trying to pull it towards itself. So equal in magnitude, the force magnitude is equal but direction is opposite. So they constitute an action and reaction pair and obey Newton's third law of motion. To every action there is an equal and opposite reaction. Then gravitational law is valid for point masses. So what is the concept of point mass? So here what I am trying to say, I told that the separation distance between the centers, okay, I told that the centers are separated by distance r. So the point mass is the concept where it is visualized that the entire mass of the object, okay, the entire mass of the object, it is concentrated at one point, which is basically the center, okay, the center of mass of the system. Okay, the entire mass of the object or the body, whatever shape and size it is concentrated as a center point. Okay, the center of mass of the body. So it is that point which is visualized as a point mass. Okay, the concept of point mass is taken from there, where the entire mass is concentrated at a certain point. Okay, so that's why we consider spheres whenever we take it our analysis for gravitation. We take spheres because the entire mass is concentrated at the center. Okay, so it becomes easy to visualize the whole thing. So this is the concept of point mass. The gravitational law is valid for point masses. Then we have the gravitational force is a central force. That is, again, the force acts along the line joining the centers of the two masses. So here the gravitational force acts along the line joining the centers of the two masses. That is, it acts along the center of mass of the body. Here also it is originating from the center, here also it is originating from the center, and both the forces, they act along the same line joining the center of mass of these two bodies, these two objects. So that's why I told in the beginning that the center concept, the separation distance between the centers of these two bodies, that is very important. So here the center of mass for the point mass and central force concept, the forces acting along the centers of the two bodies. That's why it is very important. This concept is very important. It is center of mass and central force. Okay, now the gravitational force between two bodies, it is independent of the presence of other bodies or objects. So we'll discuss it in a separate video. For now, you just understand that let us say we have several bodies, several objects present at a certain place, okay, like this. So here, say M1, M2, M3, M4, M5. So here the gravitational force between each of these two bodies, okay, it is independent of the presence of the other bodies. For example, let us say M1 and M2, they will exert gravitational attraction, gravitational force on each other. Similarly, M1 and M5, they will exert gravitational force on each other. M1 and M4, they will exert gravitational force on each other. M1 and M3, they will exert gravitational force on each other. Similarly, M2 and M4, they will exert gravitational force on each other. M2 and M5, they will exert gravitational force on each other. Okay, M2 and M3, they will also exert gravitational force on each other. So all will be independent. It does not depend on the other. Okay, all of these bodies will exert gravitational force of attraction on all the remaining other bodies. Okay, M1 will exert gravitational force of attraction on all the remaining four bodies. Similarly, M2 will exert gravitational force of attraction on the remaining four bodies. M3 will exert, M4 will exert, M5 will exert, like that. Okay, it is not dependent on the presence of other bodies. Regardless of the presence of other bodies, the net gravitational force of attraction, it will be the summation of the individual gravitational forces. So it is called as the concept of principle of superposition of gravitational forces. We'll discuss it in a separate video. For now, you just understand this. So the gravitational force between two bodies, it is independent of the presence of other bodies. It is actually the net summation of the individual gravitational forces. Next is gravitational force is conservative in nature. It means in a conservative force, the total work which is done by the force in moving a body from one point to another, it is independent of the path taken. It is only dependent on the initial and final position. So what I'm trying to say is, it is, let us say, gravitational force caused a body to move from this point to this point. It's a conservative force. Okay, point 1 to point 2. Now let's say it took this path, straight line path, like this. This is path 1. Then it took this path, path 2. Then it took this path, like this, path 3. Then it took this path, like this, path 4, or this path, like this. So no matter whichever path it takes, the total amount of work which will be done to take the body or object from this point to this point, it will stay the same under the effect of gravitational force, because it is a conservative force. It is conservative in nature. It only depends on the initial position and the final position, not the path taken to reach one point to the other. It only depends on the initial and final position, the net displacement between them. Okay, so gravitational force is conservative in nature. So if a body moves under the influence of gravitational force, the total work done by the force, by gravitational force, it will be independent of the path taken. It only depends on the initial and final points. Okay, so here are some of the important concepts related to Newton's universal law of gravitation. It is the mathematical expression, then the definition of universal gravitational constant, its value, and the characteristics of gravitational force. Okay,